and welcome to Tuesday's edition of Cracking the Cryptic. And today we have a fantastic solver turned setter puzzle for you. This puzzle is called Rex Parve, which my Latin knowledge, I should have looked this up, what it means. I think it's King of the Poor, perhaps? King of the Poor? And it's by J40, but I happen to know that J40 is the pseudonym of none other than Jan Gazelius. And Jan Gazelius is a name, if you've been following the channel, you'll probably be very familiar with, because quite often we read out the names of who solves our Patreon rewards the fastest. And it's quite often Jan Gazelius. So Jan Gazelius is obviously a phenomenal solver. And we had an email a few days ago from Peter Venus, also a phenomenal solver and setter. But Peter said that this is apparently Jan's first ever Sudoku creation, and it is magnificent. I've just looked it up on Logic Masters Germany. It's got 99% approval rating. It's quite difficult by the looks of things, but we are going to give this a go today and see how we get on. It's a straightforward, oh no, it's not straightforward arrow Sudoku. There is this is why it's called Rex. There is a King's Move restriction today as well, so King's Move in chess. So, right, now I'm starting to understand what's going on, and I will read you the rules of this one in just a moment or two. What do I need to tell you first? Mark has asked me to tell you that merch is back. And now, if you've been looking for our merch over the last month, probably, you will have found it, absent from YouTube for reasons that were not in our control. Somehow, some way, Spring, who basically make our merch for us and distribute it, somehow their programmers messed up and their linkage to our YouTube channel ceased to be, and we didn't pick up on it for a couple of weeks. And when we did pick up on it, we said, YouTube, what's going on? And YouTube had to go and investigate, and YouTube said, well, it's not us, it's Spring. So we've had to fix it with them, which it's now fixed. But so if you've ever wanted to own any Cracking the Cryptic merch, and why wouldn't you? We have got some fantastic merch. I really like the hoodies and the mugs, and I own both. So yeah, you should now be seeing notifications about that under the videos as usual. As usual in the old days. And the only other thing to mention is, of course, tomorrow is the 1st of June, and we have 2 competition Sudoku packs coming out, 4 PM tomorrow over on Patreon. Do look out for those. They are fantastic collections of puzzles, and we are very, very grateful to Panthera, to the Asylum, and to Grockles for making such fantastic gifts for our patrons. We really do appreciate it, and we hope that you guys too do as well. Now, all that said and done, let's get on with Rex Parve and see what J40, aka Jan Gazelius, has got in store for us. The rules are fairly short today. We've got normal Sudoku rules apply. Digits along an arrow sum to the digit in that arrow's circle. So those 3 cells there, you add them up. Let's say there were 1, 2, and 3. This would have to be not a 7, a 6. 1 plus 2 plus 3 is 6. So that's how arrows work. Now, 2 diagonally adjacent cells cannot contain the same digit. So that means this cell here, imagine that was a 1. Now you couldn't put a 1 in this cell, or this cell. I think most of the other cells are ruled out by Sudoku anyway. But it's sort of you can think of it either as a diagonally adjacent cell restriction or as a King's Move in chess restriction. Of course, a chess king could move to those 3 cells, and therefore none of these cells can be this digit. So that's how the King's Move restriction works. Do have a go. The way to play is to click the link under the video as usual. But now I get to play. Let's get cracking. And I think Jan's been quite generous at the start here, because all of these arrows look lengthy, or maybe not that one, but they look lengthy enough to be restricted a bit. Oh, no. Right, hang on, scrap that first thought, and I'm going to look at this syzygy straight away, because I can tell you straight away that this syzygy of circles here is 6, 7, 8, and 9 in some order. And the reason for that is because if we look at the arrow cells in row 4, let's imagine these were 4, well, they have to be 4 different digits, that's the point. So the minimum we could put into these cells would be 1, 2, 3, and 4. But the minimum we could put into those cells in row 5, because these all see each other, they're in the same row, would be 1, 2, 3 and 4 again. I'm trying to make sure the Sudoku works and failing miserably to do this. 4, and then I can make that a 1, and now I'll make this a 4, I'll make that a 1, no, not that one, that one's got to be a 3, sorry, missed out that's got to be a 1, and that's got to be a 2. So you can see in each of these rows I've put in the absolute minimum I can on the arrows in a way that doesn't seem to have broken the Sudoku, and although it would break the King's Move restriction I'm now seeing, but let's gloss over that. So the absolute minimum I can put onto these arrows is 30, because there's 1, 2, 3, 4 here, that's 10, 1, 2, 3, 4 here, that's 10, 1, 2, 3, 4 here, that's 10. And what's the absolute maximum I could make these circle digits? Well, if I make them 6, 7, 8 and 9, that also adds up to 30. So we've sort of got a min-max thing going on here. And we should, I think, therefore, do some profligate pencil marking like this to start us off. Now, that's probably going to be enormously powerful. This circle as well, although that's not in the syzygy, that is adding up 3 different digits in box 9. So that is also 6, 7, 8 or 9. This is also 6, 7, 8 or 9. These 3 digits have to be different. And yes, okay. Right, so here the King's Move comes into effect. I was about to say this is different because it's possible, in theory, I was going to say, to repeat a digit along this arrow, but it's not because of the King's Move restriction. So this cell sees that one by normal Sudoku and that one by King's Move. So this has to be different from both of those, and these two obviously have to be different from each other. So these are 3 different digits, which means they're a minimum of 1, 2, 3, which means this cell, you've guessed it, is 6, 7, 8 or 9, and the same is true here, yes. This digit sees both of those, so that is also 6, 7, 8 or 9. So at the start here we've got quite a lot of information, which is very unusual in an arrow Sudoku. Now, what we might want to think about doing is colouring these circles. Let me just think about that for a moment or two. Well, the most interesting one looks like it's this one to me. So we can ask where this cell goes in box 5. And because of the King's Move restriction and a bit of Sudoku, it's got to go in one of those cells. So this is not, well, this will rule itself out of one of these, because whichever of one of these is actually the real yellow, it will touch one of these pyramid arrows at the top. But actually, this one can only go in one of 2 positions there, and both, yeah, okay, and both of these see that one. So green is not the same as this, because if this, yeah, the way to think about that is imagine those 2 digits are the same, then you couldn't put that digit anywhere in box 4. It would be ruled out by a combination of Sudoku and King's Moves. So this is not the same as this, but that doesn't mean this is the same as that. These two have very little in common with each other. They're sort of estranged. Okay, sorry, I'm not actually seeing anything clever here at all now. My brain has given up. It's now telling me that the correct way... Maybe it's this row even, because this row, obviously it touches the syzygy here. So yellow in this row has to be in one of 3 places. This one has to be in one of 3 places. But each one of them, I think, has to be in one of 3 places, apart from perhaps this one, which has to be in one of 4 places. There's something going on here that I'm not quite twigging. I am being, what's the current expression? A beef-witted Applejohn. I'm being a beef-witted Applejohn again. Right, do not be a beef-witted Applejohn for any longer than you absolutely have to, Simon. What am I meant to spot here? That digit can't go... maybe it's this one I've got to think about, rather than these ones. This pyramid arrow here can't have that digit on it because of the king's move restriction. So maybe I'm actually meant to colour these in rather than... Is that going to actually work? I don't think it is actually, because I can't actually see how I'm going to... Like, if I was going to try and colour this digit in this box, how's that? I can obviously rule it out of those two, but it can repeat on its arrow. Oh, actually no, if I start with that digit, I can colour that digit in this box. Yeah, I'm going to have a look at that. So let us abandon our colouring here. I think the only thing we've got to try and remember is that this digit has two homes in this box, and this digit has two homes in this box, and these two can't be the same. Let's try and keep track of that in our heads, and that way we shouldn't have too many colours going on in these rows. And what I'm going to do is I'm going to start with this cell because that's the one I just saw. Let's make that green. Now you can see that because it's a 1, 2, 3 or 4, it's one of these digits, but it's not those three because of the king's move, so it's that one. And the same is true of this cell. So this cell can't be those three and has to be that one. And that's interesting actually, because now we know this one is yellow because it can't be green because it already sees green in box 5. And that sort of allows us to complete green in box 6. Okay, so now that one must be the same as that one, which is a little bit interesting, which means it's the same as this one. And these three must be the same, and we'll pick the colour blue. So what is that telling us? So purple cannot be in these cells. That cell, if that cell is a 1, 2, 3 or a 4, it can only be yellow. Here is something. Where does yellow go in row 7? That's a good question. Can't go in these two by king's move, can't go there by Sudoku, can't go there by Sudoku. That is yellow. Wow. Okay, so where does purple go in row 7? That one or... one of two, I think. What about blue then? Blue can't go here or here. One of two again. Green. Green can't go here, here, here. Everything's got options apart from yellow. That's very annoying. Right, so yellow is in one of those two cells. Right, okay. I'm a bit nonplussed by this. So, what is it? It's something, I think, around these... hang on, let's think about this differently. So each circle represents a different number. We know that in this syzygy. So one of those is 6, which means one of those is a 1, 2, 3 triple. And one of them is 9. And the only way of adding up to 9 in 3 digits, 3 different digits, there's always different numbers on these arrows, is going to be 2, 3 and 4. So one of these is 1, 2, 3. One of them is 2, 3, 4. One of them is 1, 2, 4 to add up to the 7. And one of them must be 1, 3, 4 to add up to the 8. Actually, I'm not even sure. I think that was just totally obvious what I've just said. It's totally obvious once you get this as 1, 2, 3, 4 quadruples. It can't just, I mean, there's no other way of doing it. So perhaps it's slightly progressing the course of Simon's knowledge to note that the 9 must be 2, 3, 4, but it's not really much. It's a sort of instant deduction once you think about it. Okay, so the more opposite expression is bobbins. Yellow. Purple can't go on here. So that would have to be yellow. If this arrow is made up of low digits, can we colour those digits? That's a good question. And the answer to that is that would have to be yellow. That one, I think, that one has got options, I think. This one's better now. That's quite interesting. Once you colour this one yellow, this one can't be yellow. And this one here can't be purple or blue, so that would be green. Oh, that's lovely. Okay, so that becomes blue. Isn't that interesting? So actually, if the problem here is that this arrow doesn't have to be made up of 1s, 2s, 3s and 4s. It could be 6, 1, 2, adding up to 9. But if it is low numbers, you can exactly pinpoint them. Now there might be a reason that this doesn't work. Or maybe maybe you get a repeated one over here. Right, let's check this one. So this digit can only be blue. So if this arrow is made up of low digits only, that can only be blue because it sees all 3 of those cells. And then this one sees yellow, green, and now blue, so that would have to be purple. Oh, look at that, that's so annoying. So you get 4 different ones in there, so we can't conclude yet that one of these arrows has to have high digits on it. Now this one that would have to be yellow. Let's just get rid of this pencil marking for a moment. So if these do contain low digits, if either one of them contains a low digit, that one has exact colouring attributable to it. Oh, right. No, right. That is so clever. Oh, good grief. Wow. Okay. Now, we can do Agad Meta style thing here because I've just noticed something very, very cool. There is a reason why both of these arrows is not low digits only. There is a very beautiful reason. So, if you can't see it, pause the video. I'll give you a couple of seconds. And for those of you who managed it, congratulations. Because why can't this, let's focus on this one first, why can't this be low digits only? And the answer is, if it's low digits only, it's purple plus yellow plus blue. Well, this syzygy circle here is purple plus yellow plus blue. So these would have the same total, and that's impossible because they're in the same column of the Sudoku. So let's check this one. This one is equal to green plus blue plus yellow, and this arrow is equal to green plus blue plus yellow. So it's impossible. So that means both of these arrows are not low digit arrows. So they must have a 5 or a 6 on them. which means these circles are at least equal to 8, and that must be true, because we can't repeat numbers on. Ignore the colouring. We can't do double 1 here. It's impossible. So we can't go 5 double 1 on this arrow, because these ones see each other. Every digit has to be different. So the high digit that must exist on this arrow must be 5 or 6. It must accompany a 1 and a 2 or a 1 and a 3. So there's always a 1 on the arrow. So this is lovely. This is going to get rid of... Yes, yeah, we're going to get rid of 1 from purple and 1 from green. Watch this. So, right, we've got to be really careful about this, actually, now I'm realising. Because I made these pencil marks on the presumption that this arrow had low digits on it. But now we've established that's impossible. So this is very much conjecture. I'm going to add a grey flash to it. I'm going to do the same here. Right, so because the minimum now for this arrow would be a 5, a 1 and a 2, this is at least an 8, and the same must be true here. So this is now an 8-9 pair, and because there must be a 1 on each arrow, one of those 3 cells is a 1 and one of these 3 cells is a 1. And look now at this cell. This cell sees every one of those potential cells, one of which is a 1. So that is not a 1, and the same is true here. So now we know that purple and green are not 1s. So let's find all purple and green cells and remove 1 from them. So yellow or blue is a 1. Which could be that one. So any arrow, right, here's a deduction. So any arrow that has yellow and blue on it, which includes this one and this one, cannot be the 9 arrow, because the 9 arrow is the 2, 3, 4 arrow. So that's not 9, is what I think we can say, and the same is true here. That is not 9. So in this row, 9 is in one of 2 places now. And yellow and blue are possibly 1. Wow, okay. What do we do with that knowledge? What do we do with that knowledge? The answer is, I don't know, I'm afraid. So can we somehow link this 8, 9? What we really want to be able to do is to locate this 8, 9 pair in our syzygy down here. That would be very helpful. So that one, oh, yeah, okay. That one, remember it can't go here, because if that one went there, we can't put it in box 4 anymore. So this one is one of those 2, which is sort of a little bit interesting. Now, yeah, so if this one was this one, it would go here in box 5 by force. But I don't actually see... I might be doing something, but I'm not sure what it is. How long have I had here? 24 minutes. That's not too bad. It's not too bad. It's not an easy puzzle, this. I can tell you that for nothing. This feels hard. Okay, so now, if this was the same as this... I don't know. I don't know. Right, this one, obviously that can't be the same as that one. So this one is one of these three. I don't see how to do that at all. And one of these digits and one of these digits is a high digit. I wonder if those high digits have to be different. I mean, I don't think that's necessarily true. You could have 5 on both of these arrows, I think, without breaking it. You could have a 5 there and a 5 there, for example. And then both of these could be 1s, so blue could be 1. And then you just need these two to be different to get you back where you need to with different numbers in the circles. So that looks entirely reasonable, unfortunately. Wow, okay, so it's got to be something else, I think. Oh, nearly. Oh, that was so nearly brilliant. Oh, goodness me, that's annoying. Right, I almost thought I'd done a brilliancy, but unfortunately, I haven't at all. What I just thought then was really cool. Right, I know that yellow or blue is 1. So I know one of those is a 1 in box 4. And I looked up and I saw those two digits with a 1 pencil mark. And I was like, I can't put 1 on this arrow. This arrow has to add up to 9. So it's got, because the minimum it could then be would be 2, 3, and 4. If the 1s in these columns are in those 2 cells and those 2 cells, you can't have a third 1 in 2 columns of the Sudoku. That will be a problem. So this would have been 2, 3, 4, and that would have been a 9. And that would have been a digit, which I've just noticed we haven't got. But there is a possibility that that is the silly little 1 on this circle's arrow. So if this was a 1, then yellow would be 1. So what's wrong with that? If yellow is 1, well, nothing immediate springs to mind. Yellow would appear on both of these arrows, which is required, obviously. Yes, so yellow or blue is on both of these arrows. If this was 2, 3, 4, this was 9. No, okay. So it's yellow and blue. So these are yellow and blue. So there's a 1 in one of these two. These are yellow and blue. One of these has got to be yellow. That doesn't help. I don't know. Okay, sorry. Right, we need to think about something different. Again, I think that was close to an absolutely beautiful deduction, but unfortunately, it isn't one. Now, and I just don't see how I can colour this line with. I mean, obviously, if this was a blue cell, that would be interesting, because then you couldn't have 2 low digits onto this arrow. So one of these would be high, and this would be at least 8. But that's on the presumption that this blue cell here is a real blue cell, which it doesn't need to be. If that's a high digit, these could both be low. These would be green and blue. And then this could be anything. This could be yellow or purple or a high digit. But we would know nothing about this. So, okay, what is it then that I'm meant to look at? Can I colour this arrow in? I think this arrow is perhaps slightly more likely in the sense that, but I don't actually know. Do I think that? I'm not sure I do, actually. I was going to say it's slightly nearer to the action, and therefore the king's move might come into play, but I don't think the king's move really does come into play with this cell. This cell could be high if it goes into those two positions, or it could absolutely be low providing it's not yellow, which we already know it's not. Oh, bobbins. This cell can't be blue or green. This cell sees quite a lot of this box. So if this cell is not high, if this cell is a low number, it has to go in one of those two positions. Wow, okay. So what else is it then? Is it something to do with these positions are probably the most productive, because King's move Sudoku, if you can, the digits that are in the middle of a face are sort of, if you imagine this was the top of a Rubik's Cube, these positions here are the most powerful because they obviously see these diagonally adjacent ones, which this one doesn't. And this one only sees one diagonally adjacent within the box. So maybe these two in their boxes above and below. That's horrendous. And this one, oh yeah, okay, that one is low, so it can't go in the two circles. So that one only has two positions in box 8. So wow, okay. Wow, good grief. Right, let's come back to this digit then, because that digit now cannot be low. This digit cannot be low. I don't believe it. Right, this digit here, let's ask the question, what digit is it? Now, if it was purple, you couldn't put purple in this box anymore, because purple would be ruled out from here by Sudoku and here by King's move. So this is not a purple digit. It's not a yellow digit. It sees yellow in its box. It's not blue and it's not green. It sees those in its column. So it's not able to be a 1, 2, 3 or 4, which means this is at least 6, 7. This is at 5 or a 6. This can't be 4 anymore. And one of these two squares is a 1. And this must be a 1, 2 or a 3, which means this is a coloured digit. We need to colour this digit either purple, green or blue. None of these see this. They see that, well, if it was Knight's move, we would know it was green. But unfortunately, it's not Knight's move, it's King's move. So this is 8 or 9 now. So this is, right, this is the same as one of these digits. So if, hang on, so it can't be this one, can it? Good grief, right, this is absolutely beautiful. This is absolutely beautiful. This is an 8 or a 9. But, so it's the same as one of these, but orange we know is in one of those two, both of which touch this by King's move. Why couldn't this one? Oh yes, that's right. This one couldn't be orange because it would be ruled out of box 4. So yes, so this is the same as that one, which I'm definitely colouring in. These two are the same. Now, unfortunately, I'm not immediately seeing. So that's telling us this digit is not red, which we didn't know before. So red. So yes, okay. So red in this box is in one of those two cells, which means red, neither of these is red. So one of these is red. So that's interesting a bit anyway. So imagine that was red. If that was red, it would have to be 8, because this is 8 or 9 and this is 6, 7 or 8, and the only common digit is 8. And that means I don't know what that means. Oh, hang on, I've got something here. I've got something here. I'm sure I've got it. I'm just sorry, I'm just checking this in my head because it feels weird, but I think it's true. Right. One of these is a 9. That is true. One of these is a 9. So if orange is 9, that's a 9, because this can't be for some reason. Yes, I think that was because... Yes, it's because there's a 1 on this arrow. So yes, if orange is 9, this is a 9. Now if red is 9, this is a 9. So one of those is, you've guessed it, a 9. That's not a 9, which means there is a 1 on this arrow, which means one of these is a 1, which means yellow is a 1. I've done it. I've done it. I think I've got a digit. Because now, can't I do the logic on column 2 and 3 that I was looking at before for these cells? But now I've actually got it different. Because this is now not able to be 9, it's a 3-cell arrow, it must have a 1 on it. We know one of those two cells is a 1, so that's the 2 1s for these two columns. We know there are only 2 1s in 2 complete columns of a Sudoku, and those 1s are in those cells. So neither of these can be a 1, and yet this arrow has a 1 on it, so that 1 is in the yellow position. Oh, yes, that's great. That does mean yellow is 1. So that means that this was a low digit. The only low digit it can be is the yellow digit, so that is a real yellow digit. There must be a 1 on this arrow, we worked that out, so that's got to be there, which means that's a real yellow digit, and all of these yellows become, you've guessed it, 1. So not only have I got 1 digit, I've got lots of digits. So now blue is not able to be 1 anymore. So this is not a 1. This is not a 1. This is not a 1. So this is a 2 or a 3. And that doesn't, I don't think that does help me know what this is. 1 is in one of these two positions in box 1. Oh, I've just seen something else. I've just seen something else. This is exciting now. I'm getting excited about this. I think we're going to be able to... Look, where does 1 go on this this arrow? It's not in those cells, so it's got to go here, which means that we get the 1 up here. So all of these are now yellowed. And how many 1s have we not? We've not placed... Oh, we get all the 1s. All the 1s done. But that's not the exciting thing I've seen. The exciting thing I've seen is look at this arrow, which is now a 2, 3, 4 arrow. So that is 9. As Maverick flies by over me. So this cell... Oh, this is so clever. Oh, I love it. I love it. Wow. Okay, so now we can say this is red, can't we? Because if this was orange, we've already worked out you couldn't put... These can't be the same. So because you couldn't put that digit in box 4. So once we know that this is 9, we know this is not 9, this is 8, which means that is 9, that is 9. Now we can go, we can get rid of the colouring from this cell. One of these is 8, and we don't, I think, know which one yet. But now we must be cooking with gas. So now, right, now this arrow is... Yes, we know this arrow doesn't have all low digits on it, so it is 1, 2, 5. Because if it was 1, 3, 4, it would have all low digits, and then this would also be the same total. So this is a 2, 5 pair, which I sort of feel like we probably know the order of in some way that I can't appreciate. Now, what about these two cells then? So these cells are, one of them is a high digit, so this could be 3, 5, or it could be 2, 6. And unfortunately, I don't think I have a very good way of telling you which of those is true. So we're going to have to do something else. We're going to have to think harder again. And the way to do that is... I don't know. I don't know. We must... I feel like we're getting closer though, aren't we? We're getting closer to a way to crack the puzzle. We've just got to work out how to go a bit further now. So we know this is the 8 arrow that has a high digit on it. One of these down here. So one of these down here is 1, 2, 3. Is there a way of telling which one that is? Oh, purple can't be 2 now, because purple sees those two cells. So purple is not 2. So purple is not 2. Does that mean something to us? So, no. I still think this can be absolutely 6, 7, or 8 just by making this 3 and this 2. Purple is not 2. This arrow now. Doesn't that have to have a 2 on it? That might be wrong. I'm going to think about that though. If this doesn't have a 2 on it, it can't be 3, 4 now. So the minimum it could be would be 3, 5, and this would be a 9. So this has a 2 on it, and if this has a 2 on it, that cell's a 5. And therefore that cell's a 2, which means this is green. We know what green is. Good grief. Good grief. So this loses its colour because it's definitely not blue, because it's a 5. Now these two squares cannot... These two squares add up to 8, and they're not 1, 7, and they're not 2, 6, so they are a 3, 5 pair. So there is a repeated 5 on these arrows. There was never a 6 on these arrows up here, the pyramid arrows. Green is a 2. We have worked this out. And this can't be 2, 5 because that would break this cell. So this is not able to be 8 anymore. So this is either 2, 3 or 2, 4. And there's a 2, 3, 4 triple in the column therefore. This is no longer an 8. So this square is... Oh, we already know that these aren't 2s, look, because we know that blue is not able to be 2 because green is 2. So in this column, we've got 6s, 7s and 9s to place in those cells. 6s, 7s and 9s. Well, that's not a 9, I can tell you that for nothing. If that's a 9, you can't put 9 in the middle box anymore because of the weirdities that are going on. All those couldn't be 9 by the dint of this being a 9. That 9 sees that one, and, well, in fact this 9 then rules those two out on its own, so it doesn't need any help. But therefore that's not a 9, which means this cell up here is, you've guessed it, a 9, which gets redded. And where does 9 go in box 2? It can't go there or there by king's move, so it goes in that cell, which nearly places it in box 5. I don't think we know which one it goes in. What about 9 in this box? It's got to go there, which does actually place it both in box 5 straight away. So we can do some redifying of the grid. That's further redification. And all the 9s just got done in an instant. So this is right. I mean, this is elegance personified, isn't it? It's just crazy good. It's a crazy good puzzle. Look at that. That adds up to 8 now. This is a 3-4 pair, so I don't care what the order of this is. I know it's 3 plus 4 plus 1. Last time I checked, that was 8. So this is the orange digit. This is not 8 now, and loses its colour, not its religion, but its colour. So these are the same. So orange in box 5 now can't go in cells that touch 8, so it's in one of 2 places. Orange in this box is in one of 2 places. Now, can we do better than this somehow? Probably. I can't see how to do it. Okay, sorry, I'm not spotting. Right, so let's think about... Oh, I see. So these are not actually going to be very helpful then, because it just depends on which of these is 3 and which of these is 4. That simply determines those. But okay, but we can colour the 6s and the 7s now. Oh yeah, this is good. Yeah, where does this digit go in box 5? We're definitely doing this. Right, let us renegotiate the colouring. We no longer need to colour 9s. We've got 9s done. We no longer need to colour 1s because we've got those done. So we've now freed up a couple of colours, so we don't have to over-colour far. We don't have to have too much chromatic going on. Now, this digit, let's make that yellow for a moment. Where does that go in this column? And the answer is not here by Sudoku, so it's got to go there. Which I think means these two have to be the same. Yes, neither of these can be yellow, so let's make those two red. Now, where does yellow go in this box? Well, this cell sees that one, this one sees both, and that one sees this one. So yellow goes here, and that actually gives us 8, look. Because now 8 can only go in the middle. So 8 goes in the middle, becomes orange. Oh, okay, that's a little bit interesting. So 8's position now in this box down here is overlapping with purple. So this is a very unpleasant medley of orange and purple, which I don't think I can resolve, although I'm a bit hesitant to... Well, okay, that's very important then for blue, isn't it? This can't be blue, this can't be blue, so that seems to have to be blue. Which, I'm not quite sure what that pencil mark means, so I'm a bit reluctant to use it. So this cell is not blue now, but it could perhaps be purple. So what are the digits I've not put in this box then? It's 5, that's one of the... Oh, 5 and 2 is it? Yeah, okay, look, this is a 5-2 pair, which is strange. Okay, okay, I don't know what to do now. So now we shall argue about... This box needs red in it. Where does red go in this box? It's got to go here. So that's a 6 or a 7. This box now hasn't got 5 in it, so that's a 5, and that's a digit, which is very welcome. Yeah, okay. Now simple question, where does red go in box 6? Has to be here, and in taking that cell, it removes the ability of that cell to be an 8, I think. So 8 moves down here and gets orangified. 8 gets placed over here and gets orangified. 8 gets placed here, and that's absolutely gorgeous, because look, now this can't be, this has to be purple, which means it's 3 or 4, which means this, you've guessed it, is none other than 8. How many 8s have we got? Loads. So we can, yes, 8, 8. This can't be 8 by King's move, so that's 8. Orangify it, and that must be the last 8, which goes here. So 8s are done. Now, what about yellow in this box? That can only go in one place. I think it feels like we're sort of progressing towards a full colouring. We need to put red in this row. That can only go here. This cell now is 5 by SUDOKU. 5 is in one of those two cells by SUDOKU. And let's see if we can keep this going somehow. Hopefully, hopefully spot some sort of logic which finishes the puzzle. Yellow in this column is now done. So, yellow over here, mate? No, not quite. Oh, yeah, okay. Where does yellow go in this box? And the answer is on top of a pencil marked 5. So this is sort of a 5 yellow combination. But that means, look, yes, so that means this is well, red has to be in one of these cells and yellow has to be in one of these cells. So this is a red-yellow combination, and there's a yellow here. So that must be the order of this. These are both 6s and 7s. These squares now are 3s and 4s. And that's a 4 by SUDOKU. That's a 3. That's the first time we've got a 4 in the grid. Now, what does that mean? Does that allow us to disambiguate these 3s and 4s somehow? I'm sure it does. I just can't see how to do it. Maverick. Right, 6s and 7s in this row are now placed in these two cells. I hope I haven't butchered this. That's got to be red, clearly. And that seems to have to be yellow. Okay, that does seem okay, doesn't it? Oh, now, but I don't know which of these is yellow. It is possible this is yellow. It doesn't have to be 5. Okay. Right. So what does that mean? How is this going to get disambiguated? Is it this something to do with this arrow? Red is in one of those two cells in box 3. But red is in one of these two cells in box 9. So we've sort of got an X-swing on reds and an X-swing on yellows. What's this digit? This is a 3 or a 4, I want. Oh, that's right, this is where it happens. This is where the magic happens. That, I think, is a 3 or a 4. Let me just check. Yes, we've not put purple in this column. So that's purple. And therefore, look at this. I've got a 3-4 pair in this row, which means this square is a 2. And 2 is green. Which, yeah, that's nice. That is nice. So that's giving me a 5 here for 1, a 2 here, a 2 here, which means this square has suddenly become blue out of nowhere. The 2s get coloured. We've got a proper chromatic festival going on today. That's a 2 by SUDOKU. This is a 2 by SUDOKU. All the 2s are now done. And that means... Oh, no, it doesn't. Oh, it's so close to cracking, I think. I want to say I know what's going on in this column, but I'm not sure I do. I can see this is a 3 or a 5, but it could still be blue. But it doesn't have to be. So this cell I can absolutely see is 3, 4 or 5. But nothing seems to be looking at it in a way that's in any way useful. Oh dear, dear, dear. Oh, so maybe I just keep going with Sudoku then. Because these cells also seem to have to be 3, 4. Oh yeah, I do. Look, there's a 3, 4 pair looking up here. In fact, this column is where it's at, isn't it? That's a 5 at the top of the grid, and that does it. That gets me a 3 here and a 5 here, so this cannot be blue. And therefore this square has to be purple, and because it's a low number. And that means that purple, after all this, has become a 3. And therefore blue has become a 4. And this arrow is now adding up to, you've guessed it, 7. So red is 7. I could probably double click, but I'm a bit nervous it'll highlight these as well. So yellow is 6. Let's check. 3, 1, 2 is working. 7, 1, 2, 4 is working. This square is a 4, so the 4s all become blue. And the 3s, such as they are, all become purple. This is not a 3. In fact, this is a 4 now, which is blue. This is 9, which is telling us this has got to be a 6. So that is a yellow digit after all that, which means this is not able to be yellow. That has to be yellow in the corner. No song for you. But you do get yellowed, and therefore that must be the 5, which is uncoloured. And this seems to have to be, yeah, that has to be the red, look. Which means that gets 7'd, that gets 7'd. Remove the colour, that one gets uncoloured. These two squares are 4 and 3, which can be coloured obviously. 3s are purple. This is a 3 by purplification. That's a something, a 5 in the corner. I think I've just filled the grid. So now everybody gets very cross when I don't have full colouring. But I think I might have here. That is a wonderful puzzle though, isn't it? I think it's right. Let's see. Yay. Yay. Yeah, an hour. It's taken me an hour to solve it, so it's not an easy one. But incredibly beautiful. And some of the ideas were very original. And that is the mark not of a debut setter, but of a very experienced sort of incredibly good setter, world-class setter. So J40, aka Jan Gazelius, I hope you have enjoyed me doing Battle with Your Puzzle. It is an absolute tour de force, it really is. And I can't wait to see what you come up with next. If this is a debut puzzle, good grief. Imagine this being your first Sudoku you ever make. It's just blows you away. And thanks very much to Peter, of course, for recommending it to us. Peter's recommendations are ones to listen to, and this is absolute proof of that. So in the end, I wasn't a beef-witted Applejohn. I was for moments, but during the last hour we have dispensed with the cloak of beef-witted Applejohnness and finally emerged into the sunlit uplands of, I don't know, perhaps just Applejohnness. You let me know. I enjoy the comments, especially when they're kind, and we'll be back later with another edition of Cracking the Cryptic.